Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 1, Lesson 4 on Parent Functions Video Part 1. So, there's a lot of different parent functions, and for one thing, I'll talk about what they are, so I'm doing different videos. I think there will be 3, but there might not be exactly that much, but this is just the first 4 that we'll be looking at. And parent functions are just kind of the default function that shows what something would look like on a graph and what happens to the output based on the input. So, in a function. And you can add things to these parent functions to make them change based on the equation that you're given, but you need to know what they look like and what they do to the inputs that makes the output of fx. So here's the first one is constant. We see the equation, the default equation that can be edited, but it's if we import a value there for c is fx equals c. C is constant, so whatever c is going to make all of the outputs that. So c is not the same thing as x. You see, because we have x here for identity, but c is something else. So here's what I mean. So let's say fx equals, we have c, but let's just make c 2. That means it doesn't matter what the input is, all the outputs are going to be 2. So if you had x is the input, and it was -1, the output, which is fx or y, is going to be 2. It doesn't matter what the x is. X could be 5,286, but fx would still be 2. That's what a constant function is. Let's look on the graph what this looks like. Okay, on the graph, if everything is one value, whatever c is, that means this is going to be a horizontal line. So constant function is a horizontal line. So we said fx equals 2. That means every value is 2. Every y value is going to be 2. But x values can be anything. But all y values are going to be 2. That's why it's horizontal, if all the y values are the same. So we go up to 2, and then we just draw a straight line across, because it doesn't matter what the x value is, the y value is never going to change. It's always going to be 2. That's what it looks like on the graph. So let's erase this and look at our second parent function. You learn about some parent functions in Algebra 1, but not all of these. So identity function means that whatever x is, well, you see fx and x are the same thing. They equal each other, so that means whatever x is, y is going to be that. So it's just the same thing. So this is kind of a linear function, because remember, y equals mx plus b. If you remember that equation, the b would just have to be 0 in this case, and then there is no m. It's just really 1, and that just means that basically that just goes down to just x. So this is basically a linear function that you learned, but it's just meaning that everything is going to be equal to each other. So let's say that x is x is 3. Then fx is going to be 3 also. If x is 149, fx is 149. So that happens the whole way. So if you see the difference, fx and x aren't equal and constant. Fx is just always whatever c is. So let's look at what this would look like on a graph. So that means that everything's going to be the exact same. So if you have 0 for the x, 0 for the y, so 0, 0. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And same goes this way. -1, -1, -2, -2. And you can just see how it's going to keep going this way right through here. Sorry if that's not drawn completely correct, but that's what it'll look like. You can see that it just is a straight line, where the slope is 1 over 1, or just 1, and then the y-intercept, or b, and the equation mx plus b, y equals mx plus b, b equals 0, because the y-intercept just means where does the line hit the y-axis, which is this one, and it's here at 0. So that's what the identity function is. And if you think about it, identity, just like if you think about the identity property, that's just what it is. So now let's look at the absolute value function. Okay, well, obviously, whatever x is, you take the absolute value of it to get the fx or y. So if x is -1, then fx is going to be 1. Because when you take the absolute value of something that has those two bars beside it, it makes it positive. That's what it does. It makes it positive. So if it already is positive, it doesn't make it negative. So if x was +1, fx would still be 1, because it doesn't matter if it's positive or negative. Absolute value always makes it positive. So think about this. It can only be positive. There can only be positive values for the y. There can be negative values for the x, but there can only be positive values for the y. Here, that means that this line's going to have to be up here, and it cannot be down here because that's negative values for the y. And it can be right here because this is a negative x, but it's still a positive y, so it can be there. So now we know it's not going to go below the x-axis. So what's this going to look like? Let's say we have 0. Well, then the absolute value of 0 is 0. Oh, I'm on highlighter. Let's say we have 1, absolute value is 1, and then so forth. So for this part, it's kind of looking like our identity 1. But then if you have -1 for the x, it's not going to go down here like it did for that one. It's going to go this way because it's supposed to be positive for the y. So we just... Ooh. I kind of messed up, sorry. Let's try that again. Okay, there we go. So, it looks like a V. That's what it looks like. Oh, something we didn't talk about for the other ones is the domain and range. But that's kind of straightforward for those. But let's look at the domain and range for this one. So domain. How far does it go to the left? To -infinity. If you don't understand how to do this, please look at lesson 2. And it goes all the way to the right to positive infinity. Parentheses, once again, because that's what we have when it's infinity. But for the range, it's a little bit different. It doesn't go all the way down, no. The furthest it goes down is 0. And when it's a parent function, you have a bracket, because it is including that point. And it goes all the way up to positive infinity. And it decreases from -infinity to 0. And we use parentheses when we're talking about that. And then it increases from 0 to positive infinity. And the relative minimum is 0, 0. That's the furthest down it goes. Okay, that's our third parent function for absolute value. That looks like a V. Now, let's look at the last one in this video, which is going to be our squaring or parabola one. So parabola, hopefully you know, just means that. So we already can tell this is going to look like U. This is like when we were doing quadratics. So that means it doesn't matter what x is, you always square it to get the y. Well, you remember something. When you're squaring a positive, let's just take 2 for example, you get 4 because it's basically 2 times 2. Because you multiply the number by whatever number's up there, how many times that is. Like if we had 2 to the 23rd, we would do 2 times 2 times 2 all the way to 23 different 2's. But we're only doing to the second. Thank goodness. But if we have a negative, what happens? It's still positive. But if you have no parentheses there, then it makes it negative in your calculator. Also, if the negative is outside the parentheses, it's negative. So that's something you need to know. But in this case, it's always going to be in parentheses because that's what you do. And so all of the values are going to be positive for the y once again. So now we know we're not going to go below the y-axis this time, like with the absolute value one. So if 0 squared is 0, 1 squared is 1, negative 1 squared is also 1, 2 squared is 4, or wait, sorry. So if we have 2, then the y is going to be up here, sorry. And then 4 here, and then when we go to 3, we get up to 9, so all the way up here, and then here. If you notice something, this looks symmetrical. We'll talk about that in a minute. So we see it curves, and it's kind of like a U. This is just a parent function, but depending on what values you could add to x squared, it might end up like this. So that depends on how much curve there is. We'll talk about that in a different time. So that's what that looks like. What's the domain? Well, it goes all the way to the left and right. So negative infinity to positive infinity. The range, though, it's the same as the last one. It starts at 0 and then goes all the way up to infinity. Is the graph even or odd? Okay, for one thing, you might be saying, what's even or odd? Well, even, here's what it is. If it's even, then it's going to be able to bend in half this way. So imagine if I took this side and folded it over. And so it's kind of like this. Folded, I don't know how to draw that really, sorry. If you just basically folded this graph on the x or y axis. You folded it right here. So you folded it and then you folded it. Would it be symmetrical? Yes, it would. So that means it's even. And what if it's odd? If it's odd, that means that it has rotational symmetry. That doesn't mean that you folded on this axis, as some might think. It just means you could turn this graph any way and it would still look the same. There are some cases like that, so that's coming soon, okay? And so it's symmetric with the y-axis. The relative minimum is at 0, 0 because that's the lowest point, and then it decreases from negative infinity to 0, and it increases from 0 to positive infinity. And the graph looks like a U. So there you go. That is it for this video, because that's the first 4 parent functions, but we'll be looking at some more in the next couple videos. So hopefully you enjoyed this video, and go to my channel and then click on this unit, which is Unit 1, the playlist for that, and you can see all the videos on this unit. And you will see the next videos, unless you somehow watch this just when I posted it. It might not be up quite yet, but it probably is. Just look at the date, and if it's after when I posted it, then yeah, it's probably that episode or lesson is probably there. So there you go. That's it.